and welcome back to another episode of All the Mods 9. Right before starting this episode, I did update to 0.2.54, and I'm happy to say that with that update, we can now process crude oil. You'll also notice it's Easter, so Corel Tombstone is throwing Easter eggs everywhere. But yeah, you can see our crude oil is being used and distilled very rapidly. And this area is now quite loud as the distillation towers kick off, the cracking units kick off. We're cracking everything into lightly hydro cracked over here, lightly steam cracked, and heavy steam cracked right here. And then we're distilling it all. Something I did want to mention, so you notice my chemical reactor that makes titanium tetrachloride, how every single fluid slot has 16 buckets of chlorine gas, how it like overflows and spills into the other inputs. Because I set up, this interface to store chlorine gas and to just have a pump on the side that imports that gas. So you may be wondering how exactly I prevent that from happening with these chemical reactors. I briefly talked about it, but I wanted to just kind of recap it and mention it again. So these are fluid regulators, which you can use to limit the fluids to specific quantities as a cover. And the mode I'm using is keep exact. Keep exact is what's going to take what you set in your filter and the quantity you set in your fluid filter, and it's going to keep or try to keep that exact amount inside the machine at all times. So 2 buckets of hydrogen, 8 buckets of sulfuric heavy fuel, it will always try and keep exactly that, and it's going to keep pulling the sulfuric heavy fuel in until it hits 8 buckets, and like it has stopped with the hydrogen. So like hydrogen is plentiful in here, it's just waiting for that sulfuric heavy fuel. So yeah, it's the keep exact functionality. One thing I forgot to add, but did add now, was for the methane gas to hydrogen, I decided to put a machine controller on this chemical reactor. And I'm just going to keep, when levels are above 100 buckets of methane, that's when I'll start converting that methane into hydrogen. And I started this episode at, I started earlier today at 68,000 buckets of hydrogen, and I'm already down to 67. So we are not keeping up. We do have tons of methane coming in. Just this thing taking 8 seconds is a little bit too slow. So we'll likely need to upgrade this at some point. Maybe just add more of them. I've yet to decide what to do there. But yeah, last time we set up all of this and now it is all working. Just to kind of go over what we set up, we're distilling crude oil that we get from our oily bees. We desulfurize it in these chemical reactors with hydrogen. We then lightly steam crack the naphtha, heavy steam crack the heavy fuel, or severely steam crack it, and we hydro crack lightly. We lightly hydro crack light fuel and the refinery gas. And then we distill all of those cracked fuels So like this one gets the lightly hydrocracked refinery gas. It has the 3 outputs. The light fuel goes in the 6 output one. And naphtha and heavy fuel both go in the 11 output setup. You can see if I switch my view in AE2 to just show fluids, we've got a lot of fluids now. We're starting to get to back up on hydrocracked light fuel, backing up on, well, a lot of things. Regular light fuel, refinery gas, methane gas. And we're starting to build up buffers of benzene, propene, butadiene, butene, toluene, ethane, a little bit of hydrogen sulfide. We are electrolyzing that for hydrogen. And that's about it that we're getting out of crude oil distillation. But I think they're all working properly. Not sure why this is set to lightly hydrocracked heavy fuel. This one should be the light fuel. There we go. It's always worth double checking these things. Easy to miss. You put heavy fuel when you meant light fuel, for example. And yeah, we did make that wire. And I already pulled the buckets of these out. The raw oil bucket, since this is GregTech's raw oil, I will not keep it. Because we're using the thermal series raw oil. And I need to make polydimethyl siloxane to make liquid silicon rubber. I also need to make styrene to make raw styrene butadiene rubber to make liquid styrene butadiene rubber. But I thought something that could be a nice little break, you may have already noticed it in my inventory, is to make the super critical phase shifter, or SPS. So I went ahead and made some pellets so I could make the casings. You just need polonium and plutonium. I think it was like 300. And the nice thing about these is if I look at the uses on the casing, I can see this tab on how to build the SPS. Say I want 3 ports, and I definitely want to use structural glass. It tells me you need 60 of these, 3 ports, 1 supercharged coil, and 123 structural glass. You could also say you don't want to use structural glass, in which case it costs more SPS casings, but the structural glass you definitely want to use because it's just steel and glass as opposed to polonium and plutonium pellets with these HDPE sheets. And if you didn't know, All the Mods 9 has this neat thing, or custom ponders. So you know how in Create, you can ponder pretty much any item and it gives you a little display. The SPS has one too, showing you how to build it. That essentially you need a little 5x5 kind of fat plus sign, and then you surround it with the casings. You put supercharged coils on there, and that should build it. So yeah, I thought it could be nice to do I think I have space right here to build the super critical phase shifter. And I'm just going to use the polonium that comes out of this solar neutron activator and bypass this uh, pressurized reaction chain. Because I don't need to turn it into pellets. I need to turn polonium into antimatter. You can see I'm still disposing of some waste. It takes a while for these things to go away. I think I can finally clear some of these off of my uh, pinned recipes, as well as the oily bee. Because I built the SPS, we do get an epic gem. Nice. The Gem of the Earth is very good. As you can see, it adds 2 levels to Fortune. If we make it flawless, it becomes 3 levels, and perfect, it becomes 4 levels. And I'm singling out Fortune here because sharpness and protection aren't very useful, I don't think, in my opinion. I did finish making these 64 million mega item storage cells and transferring things over. So now we've got a lot of extra storage. And we're still totally fine on fluids. Not worried about the type flashing that this is doing. I think it'll be okay. AE2 can handle it. Cool. I'm going to build the SPS. Going to try and fit it in right here if I can. And pull this pressurized tube around so that I can access it. And we will go from there. All right. Well, not very hard to make. We've just got the one supercharged laser. Is that what it's called? Supercharged laser? I think it is. There's a lot of lasers in the pack. Supercharged coil, sorry. And I limited the transfer of my flux point to 100 million FE. We're using less than 1 million FE a tick. So I figure, and we're producing 200 million from the fusion reactor. If we use half of that here, that should be okay. All that's left to do now, see, I pull our solar neutron activators straight over to here as an input. All that's left to do now is turn on our reactor. Our reactor is water cooled, and I believe you can see I just trashed the steam it makes. We don't make power from this fission. This is solely for antimatter. I set my burn rate to 550. The max burn rate is much higher, but if we go higher than 550, we risk damaging our fission reactor because our fission reactor is just water cooled. Water cooling can only keep it so cool. If we did sodium, the burn rate could be higher than 550, but I'm not worried about switching to sodium or anything like that because with our setup here, the like 3 chemical oxidizers and 2 infusers, you know, this is not going to keep up for us with a burn rate of 550. Well, let's go ahead and turn it on. You can see the temperature is just under 1.2 thousand Kelvin. I believe at higher values, that's when it starts to cause problems. And we're making about 27, 28 millibuckets of polonium, it looks like. Even though we're putting in 100 million Fe a tick, and it is using it all, I think I could probably lower this to like 10 million and have it still be just fine. So yeah, at maximum processing rate, this thing, if we look at the recipe, we could calculate exactly. The energy input for 1 millibucket a tick is 200 million Fe a tick. Since we're doing 0.028, then we only need, well, then I have to think of what is 1 divided by 0.028. We'll call it 36. So we only really need to give this thing 5 million Fe a tick. Or like 6 maybe. We'll keep it at 10. It's fine. Now we should be storing excess waste in this pressurized tube. My only concern is that we don't have enough storage space for it for overnight. For these solar neutron activators, it probably is fine once we run out of fissile fuel. Once we get through the backlog and we're just generating new fissile fuel. Yeah, we're only making this 256 millibuckets at a time. So it might be alright at a burn rate of 256. But I think at 550 we may overflow in terms of nuclear waste. Something I did when I set up this reactor was add the fission reactor logic adapter, and it's set to look at excess waste. So when the reactor has excess waste, it's going to emit a redstone signal, which will power this piston, which will push the sand in front of the observer. Behind the observer is I forget what it's called. A logic adapter. It's the logic adapter. And when it receives a redstone signal, it should turn the reactor off. But I think it might be worthwhile for us to maybe not rely on that. Because I don't really feel like putting on a hazmat suit, and I don't feel like irradiating the mining dimension. So I'm going to scram this for now, so we don't run into issues there. We need a lot of antimatter. This is going to take a while. That's okay. I think I'm going to automate permanent daytime with Ars Nouveau, so that we don't have to worry about our solar neutron activator starting off ever. If that's something you haven't seen, don't worry, I'll walk you through it. But I'm going to take a little time and put it together first. And we are back. Just did a little speed running of Ars Nouveau. By speed running of Ars Nouveau, I mean, naturally, I made arcane bees for source gems. I still had to make like, I don't know, 32 source gems, maybe more like 60, but it was worth it to make the bee. Now, if I ever need source gems in the future, I'll have plenty. I also set up some botany pots. I'll show those in a bit, but one for each of the archwood logs. The only one not in here is blazing, because to make the Tablet of Sunrise, you need the blazing archwood log. And I got the saplings just from the market. So some planks, some logs, and red wool. You can get a little villager guy you can trade emeralds with for pretty much any sapling in the game. But let me explain this contraption. So what I have here, this only works in the overworld. It may work in other dimensions with a day-night cycle as well, but it did not work in the mining dimension. It's worth mentioning that out the gate. So I have a quantum ring that I set up so I could transport one channel, put a little export bus with tablets of sunrise and a crafting card. This just fills a dispenser with tablets of sunrise. This dispenser, it's hard to see, but it is pointed up at the ritual brazier. It's pointed up at the ritual brazier. And I've got some redstone links from Create. I just used the imbuement chamber to link them together as like the filter. This one sends signal, this one receives signal. To switch them from sending and receiving, all you have to do is crouch and right click the link. I've got a daylight detector right here that if you right click, sets it to not daylight detecting mode, essentially detecting moonlight instead of daylight. So once it's detecting that the sun has gone down, which should happen shortly, the redstone link right here powers, which powers our dispenser. And then we have a pulse repeater right here set to a 10-tick delay, so that there shouldn't be any delay between this redstone link receiving power from our daylight detector, powering the dispenser, which should push a tablet of sunrise into the ritual. But then you have to activate the ritual, which is what this pulse repeater is for. So 10 ticks later, it then sends one more redstone signal into the ritual, which activates it. I'm glad we saw it in action there. I made another ritual brazier, and I was going to put a tablet of moonfall to make it nighttime, which should do what this one does, just backwards. The real reason I went with arcane bees, if you don't know how to make them, you just need to make the 2 arcane bee spawn eggs with an enchanting apparatus, some source gems, and amethyst bee spawn eggs. And they can breed together. So to make the first 2, you have to make spawn eggs, but every subsequent one, you can use flowers to make more. But I really made them because I don't like waiting on an imbuement chamber. I like things to be faster than that, and bees are considerably faster. So yeah, we have automated permanent daytime. So now we can head back. We can, with impunity, turn on our fission reactor. This thing should just be able to run all the time now. Interesting. I guess I need to increase the energy limit on this thing. Right. At a reactor rate of 550 millibuckets, we should be making 55 millibuckets of polonium. Not whatever I said before. I think it was like 28 or something. Whatever. We'll leave this at 20 million. That won't really impact our power production much. I'm just using a tenth of it now. It'll be fine. And yeah, before we know it, we'll start having ourselves, we'll start getting a bunch of antimatter. My favorite thing about this, the SPS, is it just turns polonium straight into antimatter. Antimatter gets turned straight into antimatter pellets. There is no spent nuclear waste made. At all. Oops. This is fine. So yeah, now we have permanent daytime. We're getting ourselves antimatter. I think that was a good little interlude. I suppose next up for us will be finally creating this rubber. So polydimethyl siloxane dust. One of the reasons we needed to keep some methane gas around was for the creation of this stuff. Methane, chlorine, water, and silicon all together can make polydimethyl siloxane. If we had dimethyl dichlorosilane, we could mix that with water. We do not. We could also mix hydrochloric acid with methanol, but we are not making methanol. So this is the recipe I'm going to go with. All we need is a chemical reactor on program 2. And I think I'm going to put it in this chemical reactor. Right now it has no setting, no circuit, so it should be okay to set circuit 2, because recipes with no circuit can still run in one machine with the circuit set. I sure hope that made sense. Now it's time to make silicon rubber. We can just chemical react this with sulfur, as if we were making any other kind of rubber. Now I won't make this passively, because it's the mid-tier silicon rubber. We can just order it on demand when we need it. The one I'm going to consider making passively is going to be the styrene butadiene rubber. Butadiene? I'm not sure on the pronunciation there. But essentially, all we need is ethylene and benzene. We could also use ethyl benzene if we had that. But we've got ethylene, we've got benzene. We're going to combine the two. And we're going to switch our outputs, so it says styrene is the main product. Now this did not use any circuit, so we can put it in the one with circuit 1. And we'll go with, since these recipes take the same amount of time, one just uses air, one uses oxygen, we'll go with the one that makes 41 at a time. We need 15 buckets of oxygen gas. And then, same thing, 9 of those with some sulfur gets you a bucket. Suppose I forgot to make the bucket of styrene. It does take quite a while to craft, but that's alright. Primarily because it makes 41 buckets at a time, or 41 of the dust at a time. Ooh, and we got some more butadiene. Butadiene. Still not sure on that. Looks like we have plenty, though. So yeah, we could passively set up using all of our butadiene. I'm going to change my pronunciation every time I say it now. And all of our benzene into making this rubber. Since we are passively distilling all of our oil products. It's been a little while. I'll check on hydrogen. Looks like we are gaining hydrogen now, so we're in a good spot. And we've got a few thousand buckets of methane. So I think yeah, we are in a pretty good spot here. We've almost got our first antimatter pellet. And with that, we can pass go and collect our $200. Get a bunch of antimony and some soldering alloy. So there I was, knee-deep in salsa and covered in motor oil. Now it's time to make those EV machines. As well as IV, in some cases. We've got our work cut out for us. But since we took the time to really build up our infrastructure, we have tons of titanium. So we should be able to make any EV machines we want, really. The only hard part is going to be keeping up with the circuit demands. We'll see how far 94 get us. Hopefully 129 of the IV ones get us far as well. But I'll be right back while I program some recipes for EV components. And yeah, we'll go from there. Alright, but before I got anywhere in the IV age, I realized I had a problem. The daylight detector, when it starts to rain, will start sending a redstone signal, even though it's still daytime. So I'm going to try and fix that, and I decided I'd bring you along. Sorry. To fix it, I'm going to put a redstone writer from Integrated Dynamics facing down into our redstone link. This one's sending. I still need to give it the imbuement chamber filter. This redstone writer, I think I'm going to just put a little logic cable right here. Use some variable cards. We're going to just send to a world reader. We're going to have to connect these with logic to a world reader. And the weather, I'm just looking for is night. If it is night, send a redstone signal. If it is night, send a redstone signal. I guess I didn't need to logic cable over here. I could have fit this all in one block. I thought I would need a logic programmer and a variable store, but I don't think we do actually. I had no idea we could get how long until it would rain again. That's very cool. Integrated dynamics is, well, it's pretty cool. It's powerful. We're just going to use 2 redstone writers and a world reader. Let's make sure this works. And I think since I just set it to output a full redstone signal if true, I think the setup should remain the same for the other pieces. It's a shame I don't have another moonfall. I can fix that though. It looks like it's about to be night anyway. I don't know what that proved, if anything, but I think that fixes it, since this world reader should only output a redstone signal now, if it's actually nighttime. We don't have to rely on whether or not it's raining, causing any issues from the daylight detector. Cool. All right. Now I'm going to go. Oh, before I go, I don't think I ever mentioned the gas collector. I set it up here in the overworld. You'll notice they have dimension requirements. So to get air, the gas collector has to be on program circuit 1, and it has to be in the overworld. I could not have this running in the mining dimension. It just auto outputs into a dimensional tank, and that dimensional tank sits on top of our vacuum freezer. Right. Now I'm actually going to program in some machines, some components, and we'll be back shortly. Alright, so we did a little bit more than just some quick recipe programming. Doesn't look like I've done a lot in terms of quests. I did process some ores. I processed scheelite. I processed lepidolite, neodymium, palladium, and molybdenum. But the main thing for scheelite was to get this tungstic acid. previously we hadn't made any tungsten, hadn't made any EV machines, and well, I sure have now. I made the tungsten bee. That was the first thing I made, because that thing gives you tungsten dust, and as you can see, we've already got a lot of tungsten dust now. Tungsten dust from a centrifuge, a 40% chance to get 4 at a time from a Omega upgraded tungsten bee. The tungsten bee is just an ender bee and a coal bee, so very easy to breed, and it uses 1 block of tungsten. The tungsten ingot took a little bit of time in the vacuum freezer, and a significant amount of time even with helium gas in the electric blast furnace. But it was fine. We only needed 9 to make a block to then make the bee. The bee in hand, we were able to start making tungsten steel. Now it says you can make IV machines with tungsten steel, but it's wrong. We were able to make EV machines, make things like vanadium gallium. We did a few quests here and there. But to make an IV machine like the Elite Macerator, the very first thing you have to do is make the machine hull. Well, the machine casing, technically. So yeah, tungsten steel, we can make the machine casings, but you need machine hulls to actually make any machine. And you'll see we need this polytetrafluoroethylene. Say that 5 times fast. It's a PTFE for short. If we make it in a crafting grid, we need 2 sheets. If we make it in an assembler, we still need effectively 2 sheets of the stuff, but it's in liquid form. So that's a little bit easier. And going through the recipes to see how you make this. This is a lot like making polyethylene, in that you take oxygen and mix it with the regular stuff, tetrafluoroethylene, to make polytetrafluoroethylene. Or you could use air and get a little bit less. Naturally, we've done oxygen. Tetrafluoroethylene is just hydrofluoric acid and chloroform. Chloroform is nothing more than chlorine and methane. Methane we're getting from our distilleries. Chlorine we're getting from saltwater electrolysis. Hydrofluoric acid is one of those that's not too bad. It's just fluorine gas and hydrogen gas. And the fluorine we get by electrolyzing fluorite dust, which gives us 3 fluorite dust gives you 2 buckets of fluorine gas and a little calcium. So, what exactly have I done? I went through and took all of our medium voltage machines and I upgraded all of them to EV. To do that, I did have to make a high voltage polarizer. I needed this and this extruder for large pipe. I guess I didn't necessarily need this, but I wanted it. I needed the high voltage polarizer for magnetic neodymium rods, as this is a high voltage recipe. I couldn't use my medium voltage polarizer. Once it was upgraded to EV though, I just moved the recipe over. Simple as. Chemical bath, that's where we put our tungstic acid, or that's where we produce our tungstic acid. So yeah, I went ahead and upgraded all of these MV machines, as well as this ore processing setup. I switched it from being a sifter to a regular setup with a thermal centrifuge and macerator to do the palladium, molybdenum, some graphite, things like that. And then I went a little overboard. Well, maybe it's not overboard. It's probably going to help us in the future. Do need to mute all of these. These things are noisy. But what I've done here is essentially I've tried to passive as much stuff as I can. So on the left, we have an electric blast furnace running on program 1, and it's just going through tungsten dust. We've got a little machine controller. I do invert these, so redstone on, machine on. And I just have it set to, while we're below 5,000 tungsten ingots, run the blast furnace. Similarly, right next to it, we've got tungsten steel going. I do not have the machine controller and level emitter on this one because I have that on the mixer. This mixer is just mixing tungsten dust and steel dust, and I gave it a crafting card to make steel dust for us. I use Mekanism to make steel dust. It's fast enough since this is a 10-second recipe. So I made 2 electric blast furnaces to passive tungsten and tungsten steel. I made some distilleries to process diluted sulfuric acid. So there's just an interface here pulling diluted sulfuric acid. And it distills it back into sulfuric acid. We don't need to keep the diluted stuff. This one, the one next to it, is set for diluted hydrochloric acid, and it's supposed to do the same thing, but it looks like we're out of diluted hydrochloric acid. And then, as we move further to the left, I took our on-demand sulfuric acid and decided to make it passive. So we just export round-robin oxygen and sulfur dust. This gives us sulfur dioxide. I then use an interface to stock more oxygen, a fluid regulator, or rather 2 fluid regulators, one on top, one on the side here. And they are both set with fluid filters. The one on the side just imports 1 bucket of sulfur dioxide. The one on top just pulls 1 bucket of oxygen gas. Those 2 together make a sulfur trioxide. I have another interface, pulls water for this chemical reactor, and 2 regulators. And the regulators just pull the water in and the sulfur trioxide, which then makes sulfuric acid. It auto outputs into the interface, so the interface is able to take the sulfuric back in and put it into our storage. We level emit with a machine controller, and I went quite high on this. 200,000 buckets of sulfuric acid. I don't want to run out of sulfuric acid, ever. It'll be quite useful as we go on, and I don't want to wait for it to go through the whole process of making sulfur dioxide, making sulfur trioxide to make sulfuric acid. I'd rather just have sulfuric acid. Right next to it, I've got hydrochloric acid. It's just hydrogen and chlorine. And this one I didn't set nearly as high, just 10,000 buckets, an interface to stock the chlorine and hydrogen, and it just auto outputs back into the interface. Next to it, we make 2,000 buckets of polyethylene. Again, the interface is just oxygen and ethylene, which it pulls into it with a regulator to stock a specific amount. The regulators are all on keep exact. And that just makes us polyethylene. and sends it back into our interface. Moving right along, we also have where we make ethylene, sulfuric acid, and ethanol. I've only said to keep 20,000 buckets of ethylene. You want to keep both ethylene and polyethylene. Oh boy, would help if I could spell. Because ethylene not only does it make polyethylene, it also makes vinyl chloride, acetic acid, isoprene, whatever that is. It makes styrene for us. It makes vinyl acetate for us. All of these things are going to have some use for us. So we want to keep both ethylene and polyethylene in our system. In the rest of this line, we just export wheat into a compressor to make plant balls, export the plant balls automatically into the macerator, macerate that into biochaff, push that into a brewery, export water with it, biochaff and water together give you biomass. Biomass we push into this distillery, it distills it into ethanol, and then we use the fluid regulator to only pull in 1 bucket of ethanol and 1 bucket of the sulfuric acid from the interface. I figure we don't need a lot of ethanol. I could be wrong there, but so we'll see. Then we have our hydrofluoric acid production. It's just, again, hydrogen and fluorine. Telling it to only stock 10,000 buckets for us. Macerating the fluorite, electrolyzing the dust to get the acid. We just stick it into the interface. Oh, right. This interface is here so I can eject calcium dust into the system. Calcium dust is useful. Moving right along, we make the chloroform. Chloroform also makes hydrochloric acid. Just takes chlorine, methane. We push the hydrochloric acid into an interface on the side because the interface on top is what's stocking the chlorine and methane for us that we then use the fluid regulator to pull in. We use a fluid regulator on this chemical reactor to pull in chloroform, and another fluid regulator to pull in hydrofluoric acid. This makes us tetrafluoroethylene. And I put the level emitter for polytetrafluoroethylene at 10,000 buckets on this chemical reactor, because we don't need to store tetrafluoroethylene. If we look at the uses of tetrafluoroethylene, it is just making polytetrafluoroethylene. And last but not least, oxygen and tetrafluoroethylene make us polytetrafluoroethylene. We store both of them in the interface, and we also eject polytetra, or PTFE, back into the interface. And we've already got a pretty sizable amount. We've got 160 buckets so far. Oh, nice. And we've gotten a free IV machine hull. And some fluorite, not interested in that. But that's okay. Cool. So that catches you up with where I am. I have not made nitric acid. I thought about making this on a passive setup, just water, oxygen, and nitrogen dioxide. I decided, As this says, nitrogen dioxide is easy to come by, except it isn't really. We need an IV vacuum freezer and an IV distillation tower to make nitrogen dioxide the easy way. If we look closely, nitrogen dioxide at a distillation tower uses 200 buckets of ender air. If we look at the input hatch, we can see they hold different amounts of capacity. They have different capacities for fluids, and the one that can hold 200 buckets is IV. So we also need this laminated glass, and to make IV we needed polytetrafluoroethylene. So I needed to get the polytetrafluoroethylene first before I could really get nitric acid to get nitrogen dioxide. It looks like we are going to be doing a lot more with fluids, and we're going to need this large chemical reactor. It does tell us we can generalize chemical reactor recipes to a large chemical reactor with 3 input hatches, 3 output hatches, 1 input bus, 1 output bus. So that'll make our lives a bit easier. We don't quite need, I think this is 10 total chemical reactors I put down. We could do it all in one large chemical reactor. It does take a lot of PTFE, and you need an LCR, a large chemical reactor, to make polybenzimidazole, or PBI. This stuff. Might be good for us to try and make this passively as well, which looks like it's going to be a bit of a divergence. We need to make IV. We need to make EV energy hatches to run our machines at IV. Make new distillation towers. So I think we've got our hands full. This is quite the chapter. On the plus side, we may be able to jump past the IV or the EV energy hatch straight to the IV energy hatch. I think that would be quite nice, if possible. But yeah, I shall return. Oh, I forgot to mention in our Ars Nouveau sidetrack, we did complete some other quests. Oh, and we got some antimatter. I forgot we were even doing that. I think that's everything so far. Um, my antimatter did stop running for a bit. I ran out of uranium. So we're no longer making antimatter because we ran out of fissile fuel, because we ran out of uranium. So I think, yeah, we're still slowly rebuilding our backlog of uranium, making currently uranium hexafluoride, then uranium oxide, then yellow cake, and then just regular smelted uranium. Yeah, we are largely out. That's okay. If we look at how much antimatter we have managed to acquire, we've got a little over 2 stacks. I think we're in a good spot there. I'm not sure I need to turn this back on anytime soon, if ever. I should do the calculation for how much antimatter we need. That's not it. It takes 2 to make an improbable probability device, and 3 to make this modulating unit. Then I need 90, and we have more than 90. Plus the 32 you need to make the Greg star is only 122, and we've got 139. So I think we're in a very good spot in terms of antimatter. We never had to make wasted radioactive bees. All we needed was time. Since we were doing Greg Tech anyway, we had ample time. I am running nichrome at the minute. I was tired of waiting for nichrome ingots, so I ordered 1,000. You can see it's been running for the last 3 hours, and it's barely halfway done, or less than halfway done. So yeah, Greg Tech affords us plenty of opportunities for time. Which is fine. I'm gonna keep working my way through IV. I'd like to get this coil upgrade. And to get that, I need to start doing the platinum line. I know it's called the platinum line, and we don't need the platinum at all. We need the ruthenium. And it starts you off with IV machines. So yeah, as we were saying, each quest, each chapter gets more and more non-linear. We had to come over here to polytetrafluoroethylene. To even think about making these IV machines. So I'm going to make some IV machines. I'm going to make large chemical reactors. I'm going to see if I can't jump from the high voltage energy hatch directly past extreme voltage to insane. And we'll see the results of that shortly. There we are. We've got a little setup here for indium dust. All it does is it just takes raw galena, crushes it, sends it into this ore washer on program 2, which is getting water from an export bus, getting the crushed galena, and purifying it. Similar thing on this side, we're doing sphalerite, crushed sphalerite, purified sphalerite, program 2. Program 2 makes sure you get no byproducts. A little interface right here. We've got robot arms to pull in just one sphalerite, one galena, purified. And the interface is stocking sulfuric acid. We just use a pump to import that sulfuric acid. Right in front of it is the chemical reactor. It's getting the indium concentrate. There's an interface on it. And it's pulling in with a robot arm aluminum dust from that interface. I then have a recipe in my mixer to make indium gallium phosphide dust. And I went ahead and collected the rewards. I try not to do this off camera, but accidentally grabbed them. All we got was some rust valerite and galena, a bit of indium dust, and a bit of indium gallium phosphide dust. To make the indium gallium phosphide, you need indium, gallium, and phosphorus. Phosphorus, if I ask it to craft it, it's going to, I want to say, electrolyze 5 phosphate dust. The phosphate dust is something we're getting from ore processing tricalcium phosphate, as well as centrifuging 5 tricalcium phosphate dust to get 2 phosphate dust and 3 calcium. So I did set up ore processing here, just put through like 6,000 tricalcium phosphate dust for it to go through. And it's it's processing away for us. We've got ourselves indium gallium phosphide dust, which is something we need to make this high power integrated circuit. The thing I realized is I need vanadium gallium, which you can extract the ingot. The ingot is something you have to vacuum freeze the hot ingot. The hot ingot, you see right here, requires the RTM alloy block or coil to cook, which is not ideal for us, because while I was able to make the centrifuge and the macerator, Aqua Regia is nitric acid and hydrochloric acid mixed together, and the nitric acid requires nitrogen dioxide, which we can get by distilling ender air in large quantities, which is what I want to use to get it. But I need a distillation tower at IV. Like we said before, I need the IV hatches. And I wanted to do all of that to get RTM alloy coil blocks to try and skip making these EV energy hatches. I should have known, though. GregTech doesn't really do skips. So I won't be able to skip the EV energy hatch like I had initially hoped. And instead I am going to have to make EV energy hatches for a distillation tower. We can go ahead and make several of these. We'll make 2 distillation towers, one for nether air, one for ender air. We'll make our gas collectors and place them in those dimensions. And we'll get started on making nitric acid. But I think I'm going to have to save this for the next episode and work our way through the IV energy hatch. Maybe get some polybenzimidazole. Anyway, if you managed to make it through to the end, thank you for watching. I hope you've had a good time. I know I did. And I hope to catch you next time. Bye-bye.